for example.
Okay.
So when we say that electrons are points, what we mean is that we've looked for evidence as to, like, where is the edge of an electron? If I put a bowling ball, I don't need to put a bowling ball, let me put this ball in front of us and say, where's the edge? Well, you can just point to it. There's the edge, there's the edge. What if it's too small for us to see, and I ask you, where's the edge? You get some light to shine on it and see if you can get the light to interact with the edge. What if it's too small? What if it's smaller than the wavelength of the light? Well, then the light can't see it. You have to make an electromagnetic disturbance with smaller wavelength. Yeah, smaller than small. Way small. Make this down to about 10 to the minus 18 meters. That means this energy is roughly equivalent to Fermilab or other accelerator energies. That's where we test this idea of, oh, where's the edge of the electron? Is the electron a point, or is the electron a marble?
Is having that much energy dangerous?
This energy that we're talking about is a TeV, a tera electron volt. That's not dangerous, so long as it's not deposited in, let's say, dangerous materials. There are materials that can be dangerous.
Can we ever be scared that once you hit a certain energy level, you're going to be accelerating faster and faster, and then we cannot stop, and we're going to get to a point of masses of black holes and energies that we can?
That's a reasonable question, and at the heavy ion accelerators in places like Brookhaven Lab and CERN, which is the European facility, for smashing particles and atoms and nuclei together, there was a concern that, hey, what if you smash nuclei together and you create, in those days it was strangelets, what if you create these little entities that begin to accrete? They're so dense they become, they accrete matter from around. What if, you've created a little black hole which starts to swallow the material around it, and it keeps going. And the particle accelerator in that time was Brookhaven, out about halfway out on the Long Island, and they worried, what about like New York City getting swallowed by this black hole? And the particle physicists actually sort of said, oh, that's a very reasonable question. Let me calculate the likelihood that that could happen. And it's not zero, because quantum mechanics demands that anything that could happen will. And so they calculated the probability that New York City gets swallowed by these little strangelets in the particle accelerators. And the probability was some number, I forget, it was published in the papers in 1990s, mid-90s, as something like 10 to the minus 20s.
10 to the minus 20?
So what does that mean? The probability is 10 to the minus 20. You would have to make 10 to the 20th of these events before one would be a problem. Oh, well, let's calculate how many you're going to make. And it was 10 to the 10th to 10 to the 12th. And so the probability was about roughly the same as everybody sort of buying a lottery ticket. And is there a worry that you buy a lottery ticket and win? Someone will win.
I actually bought a lottery ticket. I was worried that if I won, someone would find out and kill me. Because that actually happened recently.
And so the scientific community took that question seriously, estimated the likelihood that this happens, and reported it. And the fact that the media said, oh, you mean you cannot guarantee that it won't happen? They said, that's correct. Quantum mechanics demands that anything that could happen will eventually happen. You just have to wait long enough.
Right.
See crazy things like if we went out the door and got a drink of water and came back here, quantum mechanics, there's a small chance that your video camera disassembles atom by atom, reassembles on the roof. The probability that that happens isn't zero.
Right.
Should we try it? Should we go out and get a drink and come back and see?
Are we gonna try
10 to the, more than 10 to the 20th time is, yeah.
I don't have a
We don't have that much time, exactly. But quantum mechanics would sort of allow lots of strange things. So, yes, we did worry about that question.
Let's do our pendulum.
Okay. So, a student project from a few years back is pendulum